Important note about when you're working in assembly. So let's start a new assembly. Go into a standard assembly. When you go to add a part to an assembly, it references that part by name. And so you want to be very cautious that you're not changing the names of your parts in between doing things, or it can give some corruption issues and not being able to open things. Likewise, make sure you include all of your parts when you send me your assembly. I need to have everything in one zip folder in order for it to work. So new, create an assembly. Weldment will do week 4, I believe. And then when we want to add a piece or add a part, we're going to click place and go through our parts, wherever they are on our computer, to find parts that we want to work with. So here, let's go into our double bearing assembly, and let's start with the base. When I go to do that, I'm going to get this floating thing. If I wanted to just keep clicking, I would, and when I hit escape, it's going to get rid of them. If you click too many times, it will freeze up your computer and cause some issues. When I put something in, I am free to move it, rotate it, so on. And so we need to constrain that so that that doesn't happen. You need something in your assembly to be your base point, your grounding point, right? We need to constrain to something. If we're constraining all the, let's say, so the way you ground something is you're going to right click it and go down to ground and click that. When you see the pin, it's grounded and we can't drag it anymore. You can also right click the actual part and go click it. Either way, create the grounding or to get rid of that grounding. If we were not to ground, it's just going to add some issues to when we try to constrain things together. So let's say the bushing. Okay, so we have a bushing. One of the things we want to do is constrain the bushing so that that lines up with this, right? Apply that there. Okay, so now I want to test that constraint to make sure that constraint makes sense and that the system isn't moving in a way that it shouldn't. And so I go to click the part and drag on it, and it's just dragging my whole system, and I can't effectively test it. Whereas if I were to ground my base, then I can pull on these parts and make sure I've grounded them effectively. So basically, we're going to piecemeal it together to create grounding. So the way that we said, you can do the 2 make constraints to create an insert constraint. So we use the insert constraint here. Your constraints are going to show underneath your parts that they're associated to. So these two are the same. This popping up is asking me if I want to add an offset to it. We can see what happens. Well, I should do 10, I forget. There we go. So let's go to 10 instead of 100. You see that pulled that out 10. If I wanted to turn it to -10, it's going to push it in the other direction. Then we should have some interference. One of the ways to look for that is up here. And clicking these two, it should give us that there is some interference between them, the amount of area that overlaps the two. Okay, let's reset this so that there is no constraint here, offset here. And so we'll get something like that. If we look at our bearing assembly, these ones are lifted. That's because of that offset, because of that 10 that was added there. If this 10 was 0, we would see them looking flush with that top surface. Okay, so let's go in with two make constraints to make one insert constraint. So if I want to make this axis with, let's go on an angle so I can get it right. With this axis, I want the center axis. You see how it flipped it? Oh, maybe I did choose a, there we go. See how it flipped it? That's one of the things that kind of can get messed up with a make constraint. with using the make constraint rather than the insert constraint, it doesn't have that. Let's say I then wanted to go in and say, now I need to flip this. This face needs to mate with this face. It's giving us a little bit of craziness here. One of them may give us an option to switch it. Let's see. This mate one. Let me double click this one open. Right click it and edit it. And they're going to give us some different options here. So I can go back and change it so that it then fits the need with the mate constraints. So depending on how you constrain, you may have a couple extra things you need to worry about, a couple less things you need to worry about. But whatever it is, whatever you do, you want to kind of test things out once you get there. So let's see. Let's do the cap on this. A common mistake here would be to have a insert constraint. Let's do this one. And that one. Okay. So now from our appearance, apply. From our appearance, this looks great. That's what I wanted. That one. From this appearance, it looks great, but then when I go to grab it and test it, I see that there's that one element. I'm getting this rotational ability. There's this rotational degree of freedom that I don't want to have. That would require either another insert constraint or another mate constraint. In this case, since we have all of this super constrained already, we could just go with a mate constraint, mating this surface or this axis with this axis, that axis with that axis, or that surface with that surface, and apply, and that would then constrain it. But I don't think an insert constraint would cause any issues. It certainly shouldn't. And so then we get that same final constraint there. So be cautious about that last rotational piece of freedom bit. Are there any questions here?